Salesforce has a problem. A big, big problem. Change sets. This archaic system for change management is in dire need of an overhaul. The lack of automated tracking and the need to remake change sets in each environment makes them difficult and cumbersome to use. Even Salesforce agrees with this premise. Salesforce's DevOps Center tries to address these failures, but misses the mark. Luckily, we can use the advantages of GitHub and GitHub Actions to streamline our development workflow. My name's Justin, and I help businesses optimize their Salesforce environments. One of the big flaws of change sets is the org-based development model. This means that companies use their code inside their production or sandbox environments as the source of truth. While the scope of custom apps and the size of Salesforce orgs almost makes this a necessity, it makes it nearly impossible for developers to develop custom code. Managing the metadata and merging code is impossible in this structure. Keep in mind that with change sets, the code is overwritten, so merging code between developers is a manual task. But what if there was a different way? Thankfully, Salesforce released SFDX, now known as Salesforce CLI. This allows developers to extract the source code from the environments and turn to a Git-based Salesforce development cycle. With Git, developers can easily track changes. All changes made are automatically tracked, not only by what the change was, but who made the change. Additionally, we can use branches to model our environments. Let's say you're a small team of 2 developers. You may have the following configuration for developing Salesforce features: production, partial sandbox to merge changes, and a developer sandbox for each developer. We can think of each of these environments as elements in a pipeline. A feature request starts at the developer's sandbox and eventually gets merged into production. We can then model all of these environments as branches in Git. Master is production, staging is partial, and so on. We can then use pull requests to merge changes from one branch to another. With this model in mind, it's easy to understand how code is stored in environments and how they're related to branches. But how do we deploy code up the pipeline without change sets? Enter GitHub Actions. GitHub Actions is my favorite CI/CD tool. It allows developers to run custom code to automate deployments, test code, and more. When an event occurs in a GitHub repo, like committing code or creating a pull request, we can run custom code on these events. It even has a good free tier, so you don't need to pay for it. I talk at length here on how to configure some of these events. But let's dive into how we can use this to automate our deployments and get rid of change sets for good. To get started with GitHub Actions, we need to create a few files in our repo. At the root of our project, create a folder called .github. Inside that folder, create a folder called Workflows. This will be the place that workflows are stored for automating our code. We can then create the file validate.prod YAML inside our workflows folder. This YAML file will contain the code to validate the deployment to production. Think of this as pressing validate on a change set. First, we need to give it a name. I like the vanilla name validate production pull request. Next, we need to specify the events that this action runs on. The event pull request will run when a pull request is open in GitHub, or when additional commits are applied to the PR. We can further specify that this code will only run when the pull request targets the master branch. Additionally, we want to ensure that this only runs when making a change to the Force app directory, our main folder that stores the code. We then need to give GitHub some work to do. We can do this by defining a job for them. In this case, the job will be validate. We also need to define what operating system to use. In this case, Ubuntu latest is the best. From here, we define steps within the job. We can use pre-built actions like checkout that will take the code from our repository and use this within our GitHub action. I also created a pre-built action for you to use called sfdeploy. This takes the code from your Force app directory and turns it into a metadata package to deploy to your target environment, the sfdx auth URL. We also want the dry run flag set to true, which will run the deployment as a validation, like in change sets. We can define the Salesforce environment by feeding the sfdx auth URL to the action. This is an authenticated URL to the target environment. After you have authorized your org in the Salesforce CLI, you can run this command to get the sfdx auth URL. We can then copy the value of the sfdx auth URL and put it in the GitHub Actions secret section. Now, when a pull request targeting master branch is created, we can see the test classes ran against this code, as well as the validation of the deployment to Salesforce. This process is known as continuous integration, or CI. By the way, are you looking for more content about Salesforce DevOps? Let me know by scrolling down and hitting the subscribe button. To put the CD in CI/CD, we need to run this code as a deployment when we merge the pull request to master. We can do so by creating the file deploy to production YAML under the workflows directory. Like the last time, we'll give it a name and have it run on the pull request event. But we only want to run the jobs when the types of pull request is closed. From here, we can give jobs to the robots like merge job. We can check if the pull request is merged and then deploy with the dry run equals false. We can also specify the level of tests that we want to run. If the pull request was closed without merging, we can give the job close job to the robots and pretend like nothing happened. Now, when you close a pull request, your code is merged into production. But how can we have a pipeline with only one environment? Admittedly, that's a bit difficult. If you have GitHub Pro or GitHub Teams, you can use the environments feature to specify secrets based on the environment. Or you can give the secrets unique names. With environments, you can also enforce branch security so you don't accidentally deploy your half-written code to production. Inside GitHub, we can create an environment production. This environment will have the same secret as before for sfdx auth URL. We can then add branches that are allowed to deploy to production, like staging. We then need to define in our action that we are using the production environment. Any additional environments in your pipeline can be specified as new workflow files. The environment variable will reflect this newly created environment. And that's everything you need to know to build deployment pipelines in GitHub. Because of this automation, I have completely removed change sets from my workflow. If you enjoyed this content, I picked a video specifically for you to enjoy and learn more.